Good day everyone. I welcome you all to Shitu's Mathematics Coaching Program. We have on the board division of complex numbers. So my students have been asking since that, what if you have division that operates between two complex numbers? So how do we solve? That is the main problem they are facing. So now we don't have much problem in solving division of complex number. It just requires an understanding. At the same time, do not forget how we do rationalization of sort. So if you can be able to know the rationalization of sort, so it follows the same pattern. At the same time, do not forget that your I square is same thing as what? Your I square is same thing as -1, because you will be needing this while solving multiplication of complex numbers, or you are solving division of complex numbers. So now let me have this particular question, or before that, so now the quotient, that is division, that is z1 over z2, that is the division of complex number, it can be defined as what? At z1 dot 1 over z squared. I get it. So that's the definition of what? That's the definition of division of complex numbers. So now, if you are given any two numbers that you represent one of them to be z1 and the second one to be z2, then it will now be equals to z1 multiplied by 1 over the second one, that is z squared. So now, let's say we are given this kind of problem to solve, given z1 to be equals to 6 plus 3i and z2 to be equals to 2 minus I. So now find z1 over z2. You understand? So now we don't need to disturb ourselves here, because we've already have the definition of division of complex number as this. So the only thing you are going to do, if you want to solve, solution now. Solution. Here, z1 over z2 is same thing as z1 multiplied by 1 over z2. Oh, sorry, there's nothing like z squared. I need it to be z2 here, that is z sub 2. I have this. So now from here, what do we have? From here we have our z1 to be 6 plus 3i, then multiply by 1 over, what is our z2? Our z2 is what? 2 minus I. So now if you have this, the next thing to do here is to try, to try to rationalize the denominator of the 1 inside the bracket here, that is 2 minus I. So we don't want to see you don't want to see any form of complex number at the denominator again. So therefore we need to rationalize, that is, you multiply, that is, you have something like this, 6 plus 3i 1 minus 2 minus I, that is, you take like taking the conjugate of what? 2 minus I, you have 2 plus I over 2 plus I. Are you following? So now by having this, we have 6 plus 3i. Therefore, you try to multiply this one by this, that is, 1 times this give you what? 2 plus I over 2 times 2 give you what? 2 squared, that is 4. 2 times this one gives us what? 2i. There's minus I times 2 here, minus 2i. Then minus times plus give us minus. Then I times I is what? Is I squared. I squared. Are you getting what I'm doing now? So now from here we have 6 plus 3i, 2 plus I over, you can see 2i minus 2i. This one we go, we turn what? We turn 0. We have 4 minus I squared is same thing as what? As minus 1. Minus 1. Are you getting what I'm doing? So from here we have 6 plus 3i into brackets 2 plus i minus and minus is what is plus. We have what? We have 5 here. That is 4 plus minus 1. That minus 1. That is 4 plus 1 will give us 5. Are you getting it now? So now from here you can see this is having the denominator 1. Multiply this one by this. Multiply this one by this. We have what? We have 1 over 5 into bracket 6 plus 3i 2 plus I. So that is our final solution. So now, if you are good enough and you want to prove to be a mathematician, so the only thing you are going to do, you apply. So coming from here, so we want to simplify this one further. I get it to simplify this one further so that we have what we have, just single complex number. I get it. So now to do that, so we first try to multiply this and this together before this 1 over 5. So what are we going to do? We multiply this one by this. That is, we have 1 over 5. 6 times 2 give us what? 12. 6 times I give us what? Give us 6i. Then we are done with what? With this. That is, we've already used this to multiply the 2 terms of this in the brackets. Then we take the second one, that is 3i. 3i times this one, we have what? We have plus 6i again. Then 3i times this, we have what? Plus 3i squared. I get it. So we have 1 over 5, 12 plus 12 what? I. That is 6i plus 6i plus 3 into minus 1. Do not forget that I squared is the same thing as minus 1. So we have 1 over 5. 12 plus what? 24i minus 3. Yes, that is plus into bracket 3 into what? Into minus 1. So this is what we have here, minus 3. So we have 1 over 5. 12 minus 3. So what do we have? We have 12 minus 3 to be 9 plus what? 24i. Plus 24 plus 24i. Where do you see 24? I don't understand. So it shouldn't be 24. Yeah, it should not be 24. We have 6i plus 6i, that is 12i. Yes. If this one is 12i, so I don't know where I'm seeing the 24i. Sorry for that. So this one will be 12i minus 3. Then 12i minus 3. 12i minus 3. So from here, 12 minus 3 gives us 9 plus 12i. I get it. So if you now want to have this, actually you can leave your answer here. But if you want to have it in a separate terms, therefore we have real part and what an imaginary part. If we use this 1 over 5 to open this bracket, we have 9 over 5 plus 12i over 5. Where 9 over 5 is what is a real part, that is RE of Z, and this is what imaginary of Z. I get it. That is 12 over 5. So that is the end, and that is how we solve. You can see division also. Division of complex number also gives what? Gives back complex number, that is real part and what? An imaginary part. So that is the end for today's lecture concerning division of complex numbers. So if you have any questions, so kindly ask your question. Hit the comment box and ask any question, and I promise I will give you the possible answer to your question. So that is how we solve division of complex numbers. So I wish you good